Hello, and welcome to How Protocol Gateways May Introduce More Problems Than They Solve. If you're joining us live, our speaker is in Slido chat discussion answering your questions right now. For audio-video issues, you can click the technical support button below. I'd like to now turn it over to Philippe Lin for the presentation.
Thank you, Kathy. Hi, welcome to attend the session of How Protocol Gateways May Introduce More Problems Than They Solve. My name is Philip Lin. I'm a senior threat researcher from Trend Micro Forward-Looking Threat Research Team. And this research is brought to you by myself and my colleagues, Charles Perrin, Marco Balduzzi, Ryan Forrest, Anna Foster, and Luca Bongiorni. We're also on Slido, so if you have any questions, please just shoot. Okay, so do you have a protocol gateways in your network? You might ask, what is a protocol gateway? Or, yeah, I have several protocol gateways in my network, but where are they? So protocol gateway is usually a tiny little box that's often overlooked. And it's just like a translator that translates between two languages, for example, from English to Japanese and from Japanese to English. And in some cases, it even translates between the same language, for example, from English to American Sign Language and vice versa. So a protocol gateway translates between different physical layers of the same protocol family. For example, from Modbus TCP to Modbus RTU. Modbus TCP and Modbus RTU are just exactly the same protocol, but they are transmitted over different media. Like Modbus TCP is transmitted over the Ethernet, and Modbus RTU is transmitted over the serial lines, such as RS-232, RS-485. A protocol gateway also translates between different protocols on the same physical layer. For example, Modbus TCP to Ethernet IP. These two protocols are super different from each other, but all of them are transmitted over the Ethernet cable. Or a protocol gateway can be a combination of both, like from Modbus RTU to Ethernet IP. So in this research, we want to focus on the first type of protocol gateway. It's because Modbus is really widely used since its first standardization in 1979. And throughout this research, we have figured out a lot of serious problems that we find it's necessary to raise the awareness so that everyone can take immediate actions. And where is a protocol gateway? A protocol gateway might be in your ICS network for quite a long time. You might just not notice it. It's on one hand connected to your core switch in your control network. The control network is where we have like HMI, engineer workstation, and historians. On the other hand, it connects to the PLC, the programmable logical controller in your field network. And a PLC might connect to a subordinate devices like a relay, motor, thermometer, tachometer, actuator, and so on via another serial line, another Modbus line, or via direct digital and analog I/O. So the protocol gateway is just in the middle of this chart. It's becoming more and more complex thanks to Industrial 4.0. Right now, it's asked to support the protocols like Modbus, Ethernet IP, DMP3, Profinet, as well as some cloud protocols such as MQTT, AWS Greengrass, and Microsoft Azure. As you can probably imagine that this kind of complexity has brought a lot of challenge to this protocol gateway. And I hope you have noticed that there is an ICS firewall between the control network and the protocol gateway. This is not always the case, I have to say, because an ICS firewall is still not very frequent in this industry. And throughout this research, we have identified two types of gateways. And the first on the left-hand side is what we call a real-time gateway. A real-time gateway parses incoming packets immediately. If a packet is found invalid, it is dropped right away. Or the protocol gateway might try to fix the packet. By fix the packet, you might think, okay, yeah, there can be something wrong there in the fixing process. And if the packet is correct, no problem, it's translated and forwarded immediately. So a real-time gateway does everything at a real time. That's how it's called a real-time gateway. And it's like one packet after another, so it's a streamline. However, a data station is a little bit more complicated. It usually has one or more processes running simultaneously in the processor, and it translates asynchronously the messages by conducting one or more I/O mapping tables. And the I/O mapping table is a little bit complicated because the system integrator or a principal engineer has to set up the mapping tables according to the ladder logic of a PLC, or has to match the actual wiring inside the plant. Okay, so we were looking for the vulnerabilities in the following three aspects. The first is we want to know whether there's any vulnerability in the protocol gateway itself. Just like a legacy vulnerability research, we want to learn the firmware and see whether there is some vulnerability introduced by using the management software. And since the protocol gateway is an embedded device, its CPU and memory are usually very limited. So we want to also learn that under heavy traffic, maybe there will be some resource exhaustion and causing a denial of service. And the second aspect is the protocol translation error. So we want to learn that in parsing the protocols, maybe there's some special condition, maybe we can craft some special packet that cause a translation process to hang up and also causing a denial of service. Moreover, there can be some translation errors that, for example, some packet is not translated at all, or some packets are translated in a way that the hackers might take advantage of it and hack the PLC behind. And since the protocol gateways are supporting cloud services, we also want to take a quick look in the communication and see whether it is encrypted or secured. And the second aspect of our research, the protocol translation error, actually is the key to our work. This is what makes our research different from the traditional vulnerability research. And for a hacker who has some interest in hacking an industrial control system, this is actually a very new attack vector. With the error that we have found in translation, a hacker can conduct stealthy attacks. And since the packets are all valid, they might be able to even bypass the ICS firewall if they have installed one. So in order to do a thorough test, we have adopted and heavily modified an open source fuzzing framework called BlueFuzzer. So BlueFuzzer helps us to generate all kinds of invalid packets and monitors the unit under test. So when the unit under test is crashed, the packet is sent over the lines are logged, analyzed, and the unit under test is rebooted so that we can continue the test automatically. And this is the actual setup that we have been using. So as you can see here, we got a Raspberry Pi, the unit under test, and the Modbus serial line and the Modbus Ethernet cable. So as you see on the table that we have identified 3 real-time gateways and 2 data stations. Unfortunately, all of them got legacy vulnerabilities like resource exhaustion, denial of service, privilege isolation, information disclosure, and you even got a root shell. And 3 of them got problem in translating the protocols, which we will talk about later. And 3 of them supports MQTT protocol. However, 1 of them are really, really problematic in that there's a huge problem in user authentication. And here is a list of the devices that we have studied. We really want to make a balance between the country of the vendors, and we want to contain all the price ranges, different types, and the different underlying operating systems. As you can see, we have purchased the protocol gateways as cheap as only $200 and even the most expensive one, the Red Lion, is only $650. And Red Lion is really a fully functional protocol gateway. It supports up to 300 protocols, so you can imagine that the function is really, really complicated. And we want to cover like real-time gateway and the data stations. We want to have different operating systems because a common operating system might introduce some common problems. We want the list to be representative to the market. Okay, now let's talk about the 3 vulnerabilities. So first is the resource exhaustion or denial of service. All of the protocol gateways that we have studied has suffered from resource exhaustion. Like real-time gateway 1 and 2, we're able to just send like the first 400 packets, make 1 protocol gateway stop. And then every 1,200 packets, they crash again. And the third real-time gateway even reboots under heavy stress. So, they're not really designed for a heavy traffic. The data stations usually have a better CPU and a bigger memory. So there's no resource exhaustion on the data stations. However, since they are more complicated, we are able to craft some special packets that crash data station 1. The special crafted packet is like, I want to read the coil or read the register of register 0 at address 0. And this might not make sense to you because you think, okay, why should I read 0 register or 0 coil at address 0? Then I'm reading nothing, right? But just with this tiny special crafted packet, we're able to crash data station 1 and cause it to reboot. And data station 2 is a little bit special. It has provided a special Modbus command that a hacker has only to send a special value to a special address to make it reboot. And since this function is written in the manual, we're not saying this is a vulnerability. And however, if you're owner of this protocol gateway, you might want to know it, and you might want to block this kind of packet in the ICS firewall. And let's talk about the legacy vulnerabilities. Since the protocol gateways are often running on embedded Linux, we want to try some really good old tricks like unfiltered parameters, unescaped arguments, and so on. And we have really found something. Like, for example, on data station 2, you're able to log in as a normal user with very low privilege. And you just go to the ping test. A ping test is what's usually used to test the network connectivity. So everyone is able to use that. You just go to the dialog box and type the command, press enter. It immediately opens up a telnet session on port 9423, or whichever port that you have assigned. All you have to do is to telnet to that port. It doesn't ask for username, no password. your root immediately. So what can you do as a root? With root, you can add new users. You add new users with SSH session with a new shell so that you can make yourself persistent in this protocol gateway. You can hide there. You can add new users in the protocol gateway itself so that make yourself an administrator. You can do a lateral movement within the planet. And you can, for example, connect back to your command and control server and wait to attack the whole plant. And we have also found some credential reuse and some way to leak the IO mapping function. It's, for example, if you are a field engineer, you use the management software that can be freely downloaded from the vendor's website. You plug in your laptop, you want to inspect in the field what's going on in the protocol gateway. And the whole database got dumped and transmitted over the net. And even if the database has been encrypted, we have found a way to decrypt it, and all the configurations are inside. And moreover, the random generator is a little bit problematic. The random generator comes without seeds, which means that each time the service restarts, the sequence of random number is always the same. So they use the random number to encrypt the administrator password. That means you can always do a reply attack, and you don't even have to know the actual password. You can try to pretend to be an admin and change the settings. That's really serious. Okay, and let's talk about the protocol translation errors. And this is an example that we have found in real-time gateways. In the table, the first line is how a Modbus TCP packet looks like. And you see there's a header with transaction ID, protocol ID, message length, followed by a standard Modbus payload. And the second line is a Modbus Modbus RTU payload. So it's exactly the same payload, just followed by a CRC checksum. So if you are a designer of a very lazy protocol gateway, what will you do? You just strip off the header and add the CRC at the bottom, and you are done with the translation, right? No, this is absolutely wrong, because this kind of protocol gateway doesn't inspect the content of the Modbus payload. So if you know how to stop a POC behind with a malicious payload, you can just inject this kind of payload, and the protocol gateway will not stop it. And we have found another type of error caused by this fixing function. And you may notice that there is a big 90 in function code. So all the function code that's greater than hexadecimal 80 means that there is an error in the request. And this kind of function code always appears in the responses. So we think, okay, maybe we can just try to send a error code as a function code and see what will happen. So one of the real-time gateway just strip off the most significant bit and make this 90 a 10. A 10 means write multiple registers. So a hacker can just pretend to send an error message, and the ICS firewall would say, okay, that's an error message, so just let it pass. And actually, the hacker is able to write multiple registers. Or if we just want to tweak a coil, we can put 85, and it will be translated to 05. 05 is write a single coil. And that will cause some damages. And protocol gateway, like a data station, is more complicated. It's usually running 2 or more routines simultaneously. The first routine is responsible to parse inbound packets and set the coils and the registers in the internal memory. according to how you design this IO mapping table. And in some cases, we have found a problematic data station that just one-to-one mapping the input address to the internal memory, which allows you to overwrite whatever address in the internal memory. And the second routine usually pulls periodically the internal memory and see whether any value has been changed. If anything's changed, it would trigger a command to send the command to the Modbus slave. Now, this is how a normal operation of a data station. So as you can see on the table on the upper left side, we have the first IO mapping table. For example, command 1 means that we have one coil on slave ID 1, function 5, address 1. So one coil is just like a switch. You flip it on or off. There's no other states. Then there's a second IO mapping table that you see on the right-hand side of the table. So that means command 1 is mapped to the internal address 0. So whenever you want to change the value, or say you want to turn on the switch, what you will do is to follow the points, the bullet points. Say you send a function 5 address 1, turn on the coil, and when the data station receives this kind of message, it would map this command to internal address 0 and change this 0 to 1. And the second routine is mapped in the green background and has found that, oh, there's a 0 changed to 1. So it sends the Modbus command function 5 address 1 and turn this on. So that's how it works. Now, let's see how a hacker would abuse it. So for a hacker, my apologies, this 25 on the slide should be a 24 because the address begins from 0. So the hacker would just send function 5 address 24 and turn on. And you might ask yourself, what? There's no definition of address 24 because if you look at the table, there's right address 21 or right address 1, and there's no 24. And however, since this is a one-to-one mapping, what you are changing is, in fact, the byte 3 in the input memory. And it actually changes the 0203. It's something that you totally would not expect. Then the second routine will honestly obey this IO mapping table and find, okay, I should send a command 3, function 15 to address 21, length 50. This is something you would not expect. And what's making it worse is that if hacker can figure out where a register is mapped to, it could just like turning on a switch, it would change the value of the register. Okay, so from the slides above, we have learned that an attacker can take advantage of a leaked IO mapping table or an error in the translation. So since the packets are all valid in formats, it would simply bypass the ICS firewall. It would not be stopped. And the translated message to the PLC would cause or not cause a damage. All depends on the knowledge of the attacker. If the attacker really knows your factory very well, they know which kind of PLC you're using, which kind of RoboArm you're using, then you're totally screwed. If this is not serious enough, the attacker can top it up with the privilege escalation or to leak the IO mapping table, or just to simply use this legacy vulnerabilities to make himself an administrator of the network and change their value to fit its needs. And we want to briefly talk about the cloud vulnerabilities. In one of the real-time gateways that we have found, there is a broken confidentiality in that there's no encryption in the communication at all. Moreover, the username is always left blank. So you might connect to a rogue MQTT broker and you don't know. We have found that there's no input validation from the Modbus RTU, so that everything we have sent over Modbus RTU is repackaged and translated to MQTT side. If you have a cloud service and you don't inspect the input, you might end up with the SQL injection and got exploited in the backend. So we have learned that a protocol gateway is becoming more and more prominent thanks to Industrial 4.0. It is fundamental to IT and OT integration, but it's also a tiny little box that you might forget after deployment. And they're prone to crafted packets and might damage the PLC and even to stop your production line. And since we're able to make up valid packets, it means that the packets can pass an ICS firewall and an attacker conduct stealthy attack that you may not know. This is what we really recommend you to do in the next week. Please identify protocol gateways in your ICS environment. Have them listed in the critical asset. You might also want to know that, are there any real-time gateways or data stations? Because we have identified different vulnerabilities in real-time gateways and the data stations. And you might also learn that whether they are sending anything to the cloud. If they do, please make sure they're encrypted and secured, just like you want to do in any cloud services. And in 3 months, you're really encouraged to configure your network to protect the gateways. You might want to set up a whitelist and to allow only some IP or MAC addresses that can access the protocol gateways. You want to block all other accesses. You might want to contact the vendor and ask for a firmware upgrade and test the upgrade in the lab environment. If you are using any vendors that we have tested in this research, we're pretty sure that they are working very hard on a firmware patch. You might be able to obtain it from them. Within 6 months, you're really encouraged at firmware upgrade to scheduled downtime. You might also want to identify an ICS firewall in the market that can filter invalid packets. Please make sure that they also check the meanings inside the packets and not only check the format. So this is the disclosed vulnerabilities. My apologies that I cannot really go through all the vulnerabilities. I cannot do a deep dive because the vendors are still fixing them. We want to be responsible and we don't want your factory to be hacked because of our fault. We promise that all the technical details might be released in mid-August if there's no problems. And if you have any questions, we're on Slido, or you're more than welcome to contact us in Trend Micro Research. This is the Twitter handle of Trend Micro Research. It's at Trend Micro RSRCH. Ping us, drop us a message if you have any questions. We are really happy to help. Thank you.